In this binary search tree, blue arrow, blue arrow, blue arrow, blue arrows represent right parent-child relationship. Red arrows, red arrows, red arrows represent left parent-child relationship. When a node is given, we want to know its node's right parents, in this case node 17, or left parents, in this case node 50. Once again, in case of node 9, it has left parents 12. In case of node 14, has right parents 12. In case of node 18, this is left parents is 19. 19's left parents is 23. 23's right parents is 17. From a given node, node 14, we want to find nearest left parents. For example, from node 40, this is right parents, right parents, right parents, this is left parents. So node 40's nearest left parent is node 50. Once again, if node 18 is given, if we want to find nearest right parents, this is left parents, this is left parents, this is right parents. So nearest right parents of node 18 is node 17. We create a function like this. Return value is void. Function name is nearest left parent. And we take binary node child pointer like this. And the function name will be nearest left parent row. If m left is valid and child equals m left get, if they are pointing to the same memory, then we found through this. Now in this block, else if m parent node is valid, then we call m parent nearest left parent row, and we pass this as function call arguments. Now here, binary node pointer nearest left parent, binary node pointer child, try. We call this function by passing child. If this function returns, we failed to find. Child does not have a left parent. Catch binary node pointer ptr, then return ptr. We found left parent. Now we can create a function like this. Binary node pointer nearest left parent int value auto ptr. This find. We first find the value then return. If PTR is valid, then we call this function like this: nearest left parent PTR. Else we can simply return null PTR. So if the node with value exists and this node has a nearest left parent, then it returns the pointer of the left parent. Otherwise, returns null PTR. Now let's think about nearest right parents. Right parent row, binary node pointer child. If m right is valid and the child equals m right, get they have the same address, then return this. Else if m parent is valid, m parent nearest right parent row this. Okay, we are using recursion once again. Now I will copy this, copy, paste. Now here binary node pointer, and I modify function name like this. Now try, then we call this function, we pass child, return null PTR, catch binary node PTR, return PTR. Okay, so I will copy this function name once again, paste. Now this is value type, int value, auto PTR, this find value, return. If PTR is valid, then we call this function like this, PTR. Otherwise, we return null PTR. Sorry, I made a mistake here. We have to fix like this. PTR m parent is valid, then we call PTR m parent nearest parent. We will fix our code like this. Also, in our previous page, here PTR m parents valid, then PTR m parents, we will fix like this. Let me explain how this function works. Okay, let's consider about node 18. Node 18 has left parent. It is left parent 18, and 18 has left parent node 23, and node 23 has right parent node 17. So from node 18, we want to find nearest right parent from node 18. Initially, this is root node. Okay, this is initially root node, and we call this function like this: root, nearest, right parent. We provide value 18 because we want to find node 18's nearest right parents node 17. This function is called from this root initially, and the value is 18. Okay? In this function, we call find function. This function returns PTR. This PTR points to node 18. We are still in function root. Okay? Because node 18 has parents, so this part is true. So this node 18, this is in function root. Root's function calls PTR, this PTR, M parents. This M parents is this node. Okay? This node. M parents is node 19. Node 19. From node 19, this function calls nearest right parents by passing PTR. So in this function call, in node 19, this function block is called. Now we are in node 19. Node 19. In node 19, we call this function. So this function is called. So this is node 19 again. Node 19. And this child is traveled from here and passed it here. This is node 18. And this child is node 18. This node 18 is traveled to here. So this is node 18. In node 19, in this function, it is testing this is left child. Okay, left child. But right child does not exist. Right does not exist. So because right does not exist, it cannot compare with the child. This part holds false initially. So in this node 19, it calls this parents again. Now this function, this parents points to node 23 and calls nearest parents. Now this is node 19. Because we are in node 19, this becomes node 19. And this is passed it here. And this parents is node 23. Now we are in node 23. Okay? And this child is now node 19. In this node 23, left exists, but right is still does not exist. Right still does not exist. So this part fails again. Now this parents now becomes node 17. Node 17, and it passes node 23. Now it becomes node 23 because this. It travels here, node 23. Okay? In node 17, it has right children. This is true. Okay? This is true. And its value, right, is 23. This child is 23. So it succeeds. it succeeds. So it returns this pointer. This pointer is node 17. So this value, node 17, is returned here because it throws. Sorry, I made a mistake here. It should be throw. I should fix this part. So because it throws, it falls to here. Then this points node 17. This 17 is returned again to here through this function. So this function returns node 17. I made mistake here. It should be throw. I have to fix this code to throw this. Now let's consider about a simple one. This one. Node 67's right parents. So we initially start with root. This is root. So we call like this root. And nearest right parent, we pass the value of node 67. So we provide 67 here. This function call starts from here. So in this function, this value is 67. So this PTR points to node 67. And node 67 has parents. So this function is called from here. And this value PTR points to node 67. So this 67 is passed to here, node 67. And passed to node 67. Currently, since this 67 parents is node 54, node 54 is this parent, we are in node 54. In node 54, we call this function by passing 67. Here 67. And we are in node 54 because this is the member function. In this block, node 54, this is right child. This right is this. So this is valid. And this right child's pointer is compared with 67. So this right child points to 67. This holds true. This becomes true. So it throws this. This is 54. This is 54. This. So this value is returned through try catch. This becomes 54. So this 54 is returned through this function. So this function is returned here. Now this value 54 is returned from this function. So this function returns 54. Right parents node of 67. So we found this node. Hi everyone, my name is Thomas Kim. Today is July 13th, 2019. This is my 57th episode about the binary tree in C++. This is 9th episode about binary tree. If you haven't watched my previous episode, episode 56, please double click this link and watch my previous episode. In this episode, we will implement nearest left parent and nearest right parent algorithm for binary search tree. Start Visual Studio Code in CPP extension tutorial subfolder. You can find 056 binary tree 08.cpp. Right click, copy, scroll up, click tutorial, right click, paste, right click, rename 09 057. Hit enter and we close previous file. Ctrl V, scroll down, void nearest left parent row binary node pointer child. If left is valid, child equals left get equal, then throw this. Else if parent nearest parent row, we have to pass this. Okay, binary node ptr nearest left parent row binary node pointer child. Try this nearest left parent child. Please note that row we are calling this function, it should be removed like this. Okay, if this function return null ptr, we failed to find the nearest left parent. Here binary node ptr we found. Return ptr we found the nearest left parent. Now I will copy this function name once again. We paste. This should be element type value auto ptr this find value return ptr parent. If it is true, ptr parent, we call this function, we pass ptr, otherwise null ptr. So we created nearest left parent function. Copy from here up to this point, copy and paste Now rename it to right. And it should be right. And it also should be right. And this 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 should be right. So we created these functions. Now scroll down or Control F, print usage. In this function, we will copy this part, copy, paste. It should be 7. Left parent or right parent. For example, left parent 9. Find the nearest left parent of node 9 from the list, like this. Now scroll down. We have to find. Copy it from here. Copy, paste it here. It should be left parent. Copy this one once again, or right parent. Here the same, we are going to find this value. We will remove this part. Now we do like this. Auto left parent ptr root nearest left parent. We provide value. If valid string, the nearest left parent of the node value is left parent ptr get and there. Else copy up to this point. Is not found. And there. Now copy this part once again. Paste. it is right parent, then it should be right. It should be right. And nearest right parent, it should be right. Nearest right parent of a node is not found. I will modify this part here. Instead of doing this, I would say nearest parent. I modified like this. Nearest parents. Copy. Go up. Here, I will modify like this. Nearest parents. And nearest parents. Find the nearest left or and right parents of node 9 from the list. Start command prompt. We are using GNU compiler G++, std, C++17, 057, binary, 309, CPP, FO, binary, 3exe, hit enter. CLS, binary, 3. We are using this syntax. I will copy this part. Copy from this source code, copy, and in the command prompt right click, paste, copy, paste. We will grep first. Okay, hit enter. CLS, we grepped. From this grep, copy. From this website, Ctrl A, Ctrl B. So this is the grep. From 23, we will find nearest left node. Like this. From this grep, nearest parents 23. Hit enter. Why nothing happens? Print usage. It should be nearest parents, and in the function main, it should be nearest parents. I fixed like this. CL, EHSC, STD, C++17, 057, binary, 309, CPP, FE, binary, 3.exe, hit enter. It should be this, hit enter. So we built again. We will find the nearest parents of node 23 like this. Here, nearest parents 23, hit enter. So nearest left parents of node 23 is 50. Nearest right parents of node 23 is 17. If we try with 12, we modify it to 12, hit enter. So in case of node 12, nearest left parents of node 12 is 17, but it does not have right parents. Okay, node 12 does not have right parents. Nearest right parents of node 12 is not found. In this case, node 76, nearest left parents of the node 76 is not found. Nearest right parents of node 76 is 72. Okay, let's try 67. 67, nearest left parents of node 67 is 72. This is nearest left parents. Nearest right parents of node 67 is 54. So this function works successfully. I will post complete source code of this episode to my website extensiontalkblackboard.com. By the time you watch this video, you can click this link and download the complete source code and unzip it. In CPP extension tutorial folder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.